I'd like now to talk about aromaticity and acidity. And before we get on to that, I want to give you a little bit of background information. First of all, if we're talking about an acid, then what we're talking about is a compound that releases H plus when we put it into water. So this is reflected in that. And a Ka value then could be measured by putting the products over the reactants, A minus H plus over AH. Now we've already said that an acid produces H plus when we put it into water. So the more H plus it produces in water, the stronger the acid we say that it is. So a strong acid is going to have a high concentration of H plus, and that means it's going to have a high Ka, because that means if this number is big, then this number is going to be big as well. The other quantity we like to talk about, though, we don't really like to talk about Ka that much. We like more to talk about pKa. And pKa is the negative log of the Ka. Now the relationship between pKa and Ka is as follows. Let's say we had a Ka of 10 to the negative 3 and another one that had a Ka of 10 to the negative 5. The pKa would be 3. That would be the negative log of the Ka. Just a good rule of thumb here, if you want to take the negative log of something, then all you need, and you've got 10 to the negative something, then all you need to do is just take the digit next to the negative sign. That will give you a pretty good estimate of what the pKa is. In this case, pKa is 3. In the case of the Ka being 10 to the negative 5, the pKa is 5. What I'm trying to convince you of here is the bigger the Ka, the lower the pKa will be. So 10 to the negative 3 is bigger than 10 to the negative 5, but pKa of 3 is lower than pKa of 5. The conclusion we reach then is that the stronger the acid, the lower the pKa, and that's really what I want you to focus on. The stronger the acid, the lower the pKa. A base is defined as a compound that produces OH minus when it's dissolved in water. And instead of using Ka, we use another expression called Kb. The reason we know to use the Kb is because we've got OH minus in the products. The reason we know we use Ka here is because we've got H plus in the products. We do the same thing. Kb is AH times OH minus over A minus. A strong base has a high OH minus and therefore has a high Kb. So if this number is big, then this number is big as well. Now the pKb is a negative log of the Kb, and again we can do the same analysis as we did before of the Kas, and what we can find out is that the stronger the base, the lower the pKb value will be. And that's the important thing. Stronger acids have lower pKas, stronger bases have lower pKbs.